This video is entitled Missing Data in Interactive High-Dimensional Data Visualization. It is based on joint work by Deborah Swain at Belcore and Andreas Buya at Bell Labs. In this video, we demonstrate a set of methods for the visual exploration of high-dimensional data with missing values. This includes studying the joint distribution of the missing values, looking for correlations between missingness and variables in the data set, and investigating imputation schemes. The techniques we will show are extensions of existing methods for the interactive exploration of high-dimensional data, in particular, rapid selection of views of the data, the use of multiple linked views, and brushing and identification in those linked windows. We have implemented these techniques in the XCOBY software for interactive data visualization developed at Belcore by Deborah Swain, Diane Cook, and Andreas Buya. Here's a typical XCOBY window. The control panel across the top is used to select from a set of plotting modes and interactive methods. There's usually an additional control panel on the left. At the right is the variable selection panel, in which each labeled circle corresponds to one variable in the input data. The highlighted variables are the ones that are contributing to the current plot. The centerpiece is the plotting window, containing a scatter plot that is some projection of the high-dimensional data under investigation. The data used in this video come from an experiment measuring work efficiency during exercise. They were given to us by George Reed and Ming Sun of the Vanderbilt University Medical Center. In this experiment, there were 136 human subjects. A number of covariates were available: sex, age, percent body fat, aerobic capacity, and so on. For the covariates, there were no missing values. One purpose of the experiment was to determine whether a relationship could be found between work efficiency during exercise and body weight regulation. So one thing the experimenters were interested in was the search for relationships between efficiency and some of these covariates. We'll begin our exploration by looking at pairwise scatter plots of a few of the covariates. This is a plot of percent body fat versus age. We see that the older subjects have a higher percentage of fat. This next plot is percent body fat versus sex. The right-hand bar represents the female subjects, and they have a higher percentage of body fat than the men. Here's a plot of percent body fat and height, and there's a negative correlation. The taller subjects have less fat. Here's a plot of percent body fat against aerobic capacity. This is the strongest relationship we've seen. Percent fat is very strongly negatively correlated with aerobic capacity. Let's switch axes and look at aerobic capacity on the vertical axis. Here's aerobic capacity against age. Aerobic capacity declines with age for these subjects. Here's aerobic capacity against sex. The left-hand bar shows the male subjects. They have greater aerobic capacity than the women. And here's aerobic capacity against height. The taller subjects have more aerobic capacity. Each subject was asked to perform 3 walking exercises, increasing in intensity, and then 4 step exercises, also increasing in intensity. They did these 7 exercises in the morning and then again in the afternoon. For each of these 14 exercises, various measurements were made or derived, such as mechanical work and efficiency. When subjects didn't meet the analyst's criteria for successfully completing the exercise, a missing value was assigned. Let's look at some of the mechanical work measurements. Here's a plot of the mechanical work performed during the second morning walk versus the first. The two variables are highly correlated, and the steepness of the slope indicates that the second morning walk required more exertion. The zeros along the x-axis represent missing values for the second walk. Here's the third morning walk against the first. The mechanical work performed is continuing to increase, and so is the number of missing values. Next, we'll look at the morning step exercises. Here's the second morning step plotted against the first. We see a similar pattern, a high correlation, a few missing values. Now the third morning step against the first, and then the fourth morning step against the first. We saw again a steady increase in work performed, and we also saw the number of missing values seem to get quite large. Finally, here's the fourth morning step against the fourth afternoon step. The correlation is quite high. There are many missing values on each axis. Lots of people failed to successfully complete this exercise, both in the morning and in the afternoon, and it wasn't always the same people. When it's the same people in both the morning and the afternoon, they show up in the overplotted point at 0, 0. We can't tell from this plot whether that point represents few or many subjects. Now we're bringing into the view a plot we call the case profile. With the case profile plot, we plot all the variable values for a single case. Here, that means that we are looking at the time series for mechanical work for a subject over all 14 exercises. The occasional gaps for some subjects indicate missing values. For now, we are simply excluding missing values from this plot. This individual successfully completed all 14 exercises, and you can see the regular pattern of 3 walks, 4 steps, 3 walks, 4 steps. If we plot the case profiles for all 136 subjects, then we have a plot called the parallel coordinate plot. To examine this plot in detail, we move outside Xcobie and use a paint program. Again, the first 7 measurements correspond to the 7 exercises performed in the morning, and the second 7 to the afternoon exercises. The first 3 variables show the mechanical work performed by all subjects for the 3 morning walks, increasing in intensity. The second group of 3 shows the afternoon walks. Mechanical work seems to represent the exercise exertion quite well. The 4 morning step exercises show a similar pattern of monotonic increases in mechanical work, and again the afternoon and morning results seem to be much the same. Recall that we are not now including the missing values in this plot. That is the explanation for this point hanging off in the air all by itself. This subject completed the second afternoon step successfully, but not the third. Now we turn our attention for the first time to efficiency while performing the 14 exercises. We still see the regular pattern of 3 walks, 4 steps, 3 walks, 4 steps, but the nearly deterministic relationship we saw between mechanical work and exercise intensity has certainly vanished. We'll We'll try by eye to draw a red line at the median value for the 3 walk exercises. Instead of a consistent increase, we see an initial increase and then a flattening out and perhaps even a downturn. This pattern becomes even more apparent for the 4th step exercises. Returning to X-Gobi, we can see what happens to the parallel coordinates plot when the missings are included. The missings are still represented as zeros in all plots, so when we add them to this plot, many lines appear connecting successfully completed exercises to the failed exercises down at the 0 line. Notice the many lines here at variable 7, which was the 4th morning step, the exercise requiring the greatest exertion in the morning. Many people failed to successfully complete the 4th morning step while doing fine on the adjacent exercises. Using parallel coordinate plots and scatter plots, we saw that for this data, mechanical work is monotonic in exertion, while this is not so for efficiency. We saw that for both mechanical work and efficiency, the morning and the afternoon were quite similar. We frequently noted the high number of missing values for the highest intensity step exercise. Now we're ready to look more carefully at the joint distribution of the missing values. We open a new X-Gobi window, one that contains data derived from the efficiency data we were just looking at. This one, however, contains the missingness information for efficiency, represented by jittered 1s and 0s. 1 represents missing, and 0 represents present. We'll start again with a plot of the 2nd morning walk versus the 1st. We'll use a rectangular paintbrush to focus on a group of points at a time. Here at 0, 1 are the subjects with missing values on the 2nd morning walk, but not on the 1st. The points at 1, 1 are missing on both. The lower right quadrant is empty. There are no subjects missing on the 1st morning walk, but not on the 2nd. Next, instead of moving the brush to see the missing values for a new variable, I'll simply select a new X variable, and all the missings on that variable will be contained within the brush. Here are the missings for the 2nd walk, the 3rd walk. Here's the 1st morning step, the 2nd step, the 3rd, and the 4th step. Next, we'll take advantage of the capability to link windows to examine the distribution of the missings for 2 of the covariates. We bring the other window forward. It contains a plot of percent body fat and age. As we cycle through the variables again, we can see how the missings are distributed on this plot. As you watch, try to decide whether you find any relationship between the distribution of the missing values and the overall distribution for the plotted variables. Here's the second walk, third walk, first step, second step, third step, and the fourth morning step. We think we see a correlation between the missings and, in particular, percent body fat, the vertically plotted variable. We'll go through them again, and you can see if you agree. The third morning walk, first step, the second step, third step, fourth step. To explore this relationship further, we created a new variable, the number of missing values for each subject. And now we're plotting percent body fat against the number of missings. The number of missings ranges from 0 to 14, the total number of exercises. And you can see here a positive correlation between percent body fat and the number of missings. Using the missing values plot, we saw again that the number of missings increased with exertion. We further saw a correlation between missingness and the percentage of body fat, and a correlation between the number of missing values and the percentage of body fat. Now let's consider the graphical investigation of imputation schemes. Users can supply to Xcobie files containing multiple sets of imputations that they have computed using any method and any software they choose. Once Xcobie has read in the supplied data, the imputed values are then available for interactive visual exploration. Imputation schemes can be evaluated and compared. Here's a plot of efficiency for the second afternoon step against the first. We have brushed the missing values in pink. As we have seen throughout the video, the missing values are represented as zeros. Now, however, we would like to use some pre-computed imputed values to assign some other values to the missings. We bring a control panel into view. Initially, we will use a simple univariate imputation scheme. Each missing case for a variable is randomly assigned one of the present values for that variable. Each time you see a new set of highlighted points, we have performed a new random assignment of all the missing values. We are not surprised to see that this imputation scheme is quite flawed. Many of the imputed data points fall far outside the ellipse of the present values. We asked a colleague, an imputation expert, to supply us with several sets of imputed values using a more appropriate multivariate imputation scheme. We'll see in a minute how these values look. This is a distinct improvement. These points lie very close to the ellipse of the measured values. You might still notice slight flaw. Few imputed values fall within this upper region. This is our fault. We told our colleague to assume the data were normally distributed, and that isn't quite true. Using brushing and cycling through multiple sets of imputed values, We could see that the initial univariate imputation scheme was quite inadequate. The imputed values we obtained from our colleague were considerably better, but we might still improve them. In summary, we extended existing visualization methods, such as the parallel coordinates plot and linked brushing of scatter plots, to support the exploration of data sets with missing values. We explored the joint distribution of the missing values and their correlation with covariates. We also compared and evaluated a pair of imputation schemes. The XGOBI source code and sample data files are a part of StatLib at Carnegie Mellon University. This is the URL to use if you are interested in retrieving XGOBI.